Hi everyone, welcome to this tutorial on the first derivative test for local extrema. In this tutorial, I will explain the theory step by step and then we will use the Desmos software to visualize examples. By the end, you will confidently determine whether a function has local minimum, maximum or no extremum at its critical points. Let's begin. Let's start with the theory. First derivative test is a method for determining whether a function has local minimum, local maximum or no extremum at its critical point C. Step 1. Identifying critical points. These occur whether the derivative f of x equals 0 or does not exist. Step 2. Analyze the sign of f of x on either side of C. The behavior on the function depends on how f of x changes as we move across C. If f of x changes from negative to positive, the function has local minimum at C. If f of x changes from positive to negative, the function has local maximum at C. And if f of x does not change sign, the function has no local extremum at its C. Part 2 example in Desmos. Now let's bring this to life in Desmos. We will work with the example f of x equals x cubed minus 3x squared plus 1. Open Desmos and type the function f of x in the equation bar. Next, add the derivative f of x equals 3x squared minus 6x in Desmos. This equation will help us analyze the slope of f of x. Now identify critical points. Critical points are where f of x equals 0. In Desmos, add this equation, you will see two critical points, x equals 0 and x equals 2. Finally, analyze the behavior around critical points. Let's check for a sign of f of x around x equal 0 and x equal 2. For x equals 0, f of x is greater than 0 to the left and f of x is less than 0 to the right. This means f of x has local maximum at x equals 0. For x equal 2, f of x is less than 0 to the left and f of x is greater than 0 to the right. This means f of x has local minimum at x equal 2. Finally, zoom into these points in Desmos to visually confirm the turning points. The graph clearly shows the peak at x equals 0 and a valley at x equal 2. To recap, the first derivative test is a powerful tool to clarify critical points. Remember, negative to positive is local minimum and positive to negative is local maximum and no sign change means no extremum. By combining these tests with Desmos, you can both calculate and visualize these behaviors to enhance your understanding. Now we will explain the second derivative test for local extrema. This method helps us determine whether a function has local maximum, a local minimum, or neither at a critical point. By analyzing the first and second derivatives, we can clarify the behavior of a function. Let's break it down step by step. To use the second derivative test, follow these steps. Step 1. Identify critical points. First, find the critical points by solving f of x equals 0 or where f of x does not exist. There are the potential location of local extrema. Step 2. Analyze the second derivative. At each critical point, evaluate the second derivative f of x. If f of c is less than 0, the function is concave down at x equals to c, meaning there is a local maximum. If f of c is greater than 0, the function is concave up at x equal to c, indicating a local minimum. If f of c is equal to 0, the test fails, and we need to use other methods like graphing or first derivative test to analyze the behavior. Now let's see the second derivative test in action. We will use the function f of x equals x cubed minus 3x squared plus 2. Now in step 1, find the critical points. First we will find the derivative, which will be f of x equal 3x square minus 6x. Now solve for f of x or equal 0, which will be 3x times x minus 2 equals 0. So this so the critical points are x equal 0 and x equal 2. In second step, evaluate the second derivative. The second derivative f of x equals 6x minus 6 at x equals 0, which will be at x equal 0. It's going to be f of x equals f of 0 equals 6. Sorry, I am going to rewrite it. F of x equal f of, which is x is 0, so it will be equal to 6 x, which is 0, minus 6. It's going to be equal with minus 6. So it means that minus 6 is less than 0. Minus 6 is less than 0, which is this means f of x has a local maximum at x equals 0. So it is local maximum at x equal 0. Now we will do the same process for x equal 2. At x equal 2, f of x equals f of, which is 2, it's going to be equal with 6, 2 times 2 minus 6 equals to 6. So it's greater than 0, and this means f of x has a local minimum at x equal 2. So we will write it local minimum and to summarize, use the second derivative test to clarify critical points. F times c is less than 0, local maximum. F times c is greater than 0, local minimum. F times C equals 0, test fail, use other methods. Thank you for watching and I hope this tutorial was helpful.